So the statistic that is here is the number of withdrawals, but it's somehow normalized. It may not be clear about this normalization, but this normalization is the following. Basically, using von Montovin as a benchmark, we could basically take n and solve for w for this equation, plug it in here, and compare n to what it should have been. And divide n by what it should have been according to von Montovin, and we should get a number 1. So what you're seeing here is you get a number different than 1. Now these two, one should imply the other one. The only reason why we're doing this is because this is household level data. So it has so much measurement error that you want to have, you think that it may have independent information in different variables. Let me put it this way. Even though this is an accounting identity, it doesn't quite hold it data. I'll show you this. When I show you how we estimate it. So what you get from here is that the number that should be 1 is bigger than 1. So what is the picture of this? People make withdrawals that are kind of smaller than von Montovin. They make them very often, and they withdraw before they hit 0, in average, if you had to. So there is some sort of precaution, well, we call this, that's a name, we call it some sort of precautionary sort of demand of money, because you're withdrawing, you're making all these transactions before you're forced to, perhaps because of uncertainty. Think about driving and not driving in a highway and not being sure where you're going to have a gas station. So you probably don't want to, basically have to stop. Okay.
But if you have a credit card, that could eliminate a lot of the costs. Imagine I have $1,000 to drive over that stuff.
So the question is sort of whether you could substitute the downtime or not. And that will sort of have to think about whether there is separability in these decisions. In other words, is it true that is it sort of okay to think about these two decisions as separate decisions? And then there's a question, so where is that make these decisions? So a lot of places, they really don't take credit cards. So that would be an example, a simple example. But I think we know a lot about this, because not for Italy, but for Austria and for France, there are diary data that, so I'm not going to talk a lot about this is of a different project, but there are diary data, consumption diary data. So they ask you to write down in a diary every consumption purchase you make, how you paid it, how you could have paid it. Like, have you taken a cab, and then you say, well, I could only use cash, or I could have used a credit card. And this is the amount, and this is the type of good. Maybe you keep this for 2 weeks or so. Now, why I'm bringing this to the topic, because that's actually a nice model to think about probably the cash credit. So we sort of know something about these decisions, insofar as we could deduce from this type of data. So there are a lot of places, for instance, that cash is kind of the only thing that you could have done. But I don't want to get into that because I just want to concentrate in this little project first. Okay.
When you talk about precautionary, it's pretty big.
Yeah. That's why I want to say it's kind of like To us, it looked like it may change sort of the predictions for von Montovin. So we're going to talk about it. Now we're kind of lost. How do you? Okay. No, that was a bad position. Sorry, I didn't know how to recover from that. So there's also, let me just show you some interest rate data. This is disinflation in Italy. Interest rate coming down because they were sort of integrating with the rest of Europe. And this is a number that we constructed. It's another opportunity cost of cash. Think about that you have your cash and they take your wallet. So think about computing the probability based on surveys this will have time variation and variation across regions on that will really take your cash. So take every type of crime, multiply that, but if that type of crime were the fraction of times that they take your wallet, like if it's something like pickpocketing, they pretty much take your wallet, but when they steal your card, that's kind of not gonna take your wallet. So like a number like 2% means 2% per year. Okay. These numbers are high, but it's kind of Italy. These numbers actually in the US are much smaller, although violent crime is much higher in the US. Also, these numbers have variation. We're going to identify the model regardless of this, but we get a kick out of looking at this data. So this number has variation, as you may imagine, a little bit north to south, but it's mostly urban versus not. And a lot of this is picking the pocket of the tourist. Okay. So, because in the south, a lot of the crime that you have is violent crime and extortions. They also pick the pocket, but and the south is also dense. You shouldn't think of like the Godfather in the little. I mean, if you look at one of the most dense parts of Italy, they are in the south. But anyway, so and then it's inflation. Okay, so one more thing I want to show you is kind of how this is bank branches per 1,000 residents. This is the period in which there were more and more banks were entering, and also each bank had more bank branches, and there are many more ATM terminals per person. Okay, so we want to think of this as some way impacting the lowering the cost. Having more gas stations around, sort of will kind of make you easy to not. It should lower the cost. I'll return to this. Okay, so. I'll show you a little bit of the data. I talked a little bit about the difference with Van Tobin, right? I'll talk more about it. And let me go to a simple model that will capture some of the things that we want to do to get this precautionary motive, but not quite all. It will just give you some intuition for the stuff I will do later. Later on, I'll have a model that's going to be kind of more complicated mathematically, but I think you get a lot of intuition from this and some picture. So let me go to this thing that we call a steady-state model. So this is a version of Van Tobin. So this is the same identity in Van Tobin, cash, number of withdrawals times the withdrawal size. And then this one is just make this assumption. So for now, I'm maintaining the assumption that you withdraw when you hit zero. This is the part that we discussed that it's not quite in the data. But I want to sort of enter one more parameter. So I want to do two things with this. I want to parameterize technology. Okay, so let me show you the model. So the model is very simple and kind of monotonic. You minimize an opportunity cost of having cash times the average cash balances, which now can be written as C over 2n from here. So if you withdraw very often, that means that you have very little cash in average, times the cost of each of the withdrawals. So pretend that it says B times n. This is really Van Tobin. Okay, here's our change to Van Tobin, not a big change. So now I'll say it in a kind of ridiculous way, but in a way that is easy to interpret the model, and then let me then tell you what I have in mind. So imagine that the bank, instead of charging you B, it says, look, the first 5 times that we withdraw money, it's free. And starting with the 6, we charge you B. Really what we have in mind is that you go through your life, and then the main cost is the opportunity cost of time. And when there are more ATMs and stuff, then you will pass by through the ATMs more often. Think about a deterministic life. You go to a soccer match, this is Italy, every Sunday, and now so that's 1/7. And then when they put an ATM close by on the way from the soccer match to your house, then you can make a very cheap withdrawal because you were just passing by there. That's the idea. Or you're in an airport, you're stranded, you may as well just withdraw money. That sort of idea. So these are free withdrawals, but there is a limit to that. So there is this new parameter T. Okay. Except for that, this is kind of monotone. You will see why I want to do this. I want to do two things.